Welcome to our presentation on the color detecting robot. This is Aditya Ravi from first semester ISC department. In this presentation, we will discuss about the various components, working and application of a color detecting robot. The different components used are Arduino Uno, used as a microcontroller, TCS 3200 color sensor, 16 cross 2 LCD display, breadboard, and jumper wires. Now, let us look into the working of LCD. When a voltage is applied to a segment of the panel, it causes the liquid crystal molecules in that area to align in a particular way, allowing light to pass through or blocking it. We can display an image or text in the screen by selectively applying voltages to different segments of the panel. The color sensor consists of a set of filters, an array of photodiodes, and a frequency generator. The photodiode converts light into an electrical signal followed by the frequency generator, which gives a pulsating wave. The output is then processed by an analog to digital converter, which converts the analog signals into a digital value that can be read by a microcontroller. The TCS 3200 is a programmable color to frequency converter which consists of a configurable photodiode and current to frequency converter. It has an 8 cross 8 array of photodiodes in which 16 photodiodes have blue filters, 16 have red filters, 16 have green, and the remaining 16 are clear and do not have any filters. Each filter passes light of just a single color, whereas a clear filter will allow the entire light to pass through. These color-sensitive filters are known as Bayer filters. All 16 photodiodes are connected in parallel using two control pins S2 and S3. S2 and S3 are the two pins responsible for selecting the color that needs to be detected. We can instruct the sensor about which color's light density should be measured using these two pins of logic control. Later, it converts the current reading from photodiodes into a square wave, and the frequency of it is directly proportional to the intensity of the selected color. TCS 3200 also has pins S0 and S1, which are used for scaling output frequency. It is scaled to different values such as 2%, 20%, or 100% based on the inputs given to S0 and S1. In this case, we will restrict the frequency scaling to 20% for convenience. This can be achieved by setting S0 to high and S1 to low.
Hello, myself MANOJITH BHAT. Now let us look at the working mechanism of the color sensing robot. The purpose of the color sensing system is to detect the color and perform the output. In this demonstration, we have used LCD to display the output. Whenever we place an object under the TCS 3200 color sensing module, the object gets illuminated by the light from the LEDs of the TCS and the surrounding. This reflected light is taken up by the color sensor. The light is filtered through the red, green, blue, and the clear filters, and each filtered light is detected by a photodiode that generates an analog signal proportional to the intensity of the light. Later, the analog signals are then converted into the digital signal through the analog to digital converter. The frequency of the digital signal is then measured and processed by a microcontroller. Here, we have used Arduino IDE as an interface to code our program. First, we have calibrated the values of the red, green, blue based on the distance of the color sensor from the object and the surrounding intensity of light. Later, values corresponding to the calibrated values are mapped and the color is detected. The RGB values are then displayed on the LCD display in the readable format. First, the RGB values are displayed. In the second line, the corresponding colors are displayed. This is the demonstration of color sensing robot. It has three major components. First is the TCS 3200 color sensor, which detects the reflected light. Second one is the Arduino Uno, which is a microcontroller. And third one is the 16 into 2 LCD display, which displays the output. In the first row, it displays the corresponding mapped values of the RGB. In the second line, it shows the which color. First, we are demonstrating with the white paper. So when we place a white paper in below the TCS 3200 color sensor, we can see the output white and the corresponding mapped values of the RGB. Done. Okay. If we change the color to red, we can see the output as red. Similarly, we can Check for many colors, including green, blue, and black respectively. It can be checked for many colors, but for demonstration we have used 5 colors.
I am ANEESH from first year ISE, and I will be talking about the applications of color detecting robot, its limitations, and the methods to overcome them. The color detecting robot has various applications in many industries these days. It is used in manufacturing industries to sort objects based on color. It is also used in the agricultural industries to separate the good crops from the bad ones. The color detecting robot is a very useful tool for people with color blindness and visually impaired people. This device can help visually impaired people recognize and identify things with ease. The color detecting robot can be used to determine the amount of synthetic additives present in food these days. Depending on the absorption of light by the synthetic dyes in food, the concentration of the dye can easily be determined by the color detecting robot. The concentration of the dye present in food is directly proportional to the absorption of light. The color detecting robot is used to determine the pH of a solution depending on the color of the pH paper. One important application of the color detecting robot is to check the quality of fruits and vegetables. The quality of fruits and vegetables can easily be determined by the device depending on the color. This device has various applications in the medical industry. For example, certain diseases cause a change in skin color. This can easily be determined by the color detecting robot, and the disease can be diagnosed accordingly. Moving on to the limitations of the color detecting robot. It has a limited detection range. This means that the operating distance between the sensor and the object needs to be selected properly, and this requires a lot of testing. But to overcome this problem, we can use multiple sensors instead of just one sensor. This will cover a wider area and can give a more accurate reading. The color detecting robot has a limited color spectrum. The TCS 3200 sensor can detect a limited range of colors only. It also might not give accurate results for colors having similar RGB values. For this, an advanced color sensor can be used to detect a wider range of colors more accurately. Frequent calibration is required for the color detecting robot to maintain its accuracy. But frequent calibration is a time consuming and tedious task. For this, we can use an automated calibration system that can be built into the robot software to automatically calibrate the sensor depending on the surrounding factors. Due to the interference of the surrounding light, the accuracy of the TCS 3200 sensor is reduced. But this problem can be prevented using shielded sensors that can reduce the effect of ambient light and natural light of the surroundings and can give a more accurate reading. We can also use a concept called Euclidean distance to improve the accuracy of the sensor.
So hello everyone, today I'll be talking about Euclidean distance. Euclidean distance is basically a way of detecting dissimilarity in a group of purely similar and continuous data. We take the difference between two attribute values, square it, and find the summation of that. If we have a very huge data set, then the square root operation is generally omitted. Before I tell you why, we need to understand two terms. The first term is latency. Latency is the number of CPU cycles that you need to wait to get the answer to a mathematical operation. The second one is throughput. Throughput is the number of independent operations that can be performed per unit time. When you perform a single integer operation, the latency is 1. But for square root operations of float point precision, the latency is around 16 and the throughput is somewhere between 8 to 16. But you need to keep in mind that this is only for double precision. That is, you'll have two decimal places. If you want to increase this number, the latency and your throughput values will drastically increase, which will increase the cost of performing a square root operation on your CPU. And when you have a huge data set, this operation must be performed a lot of times
and can prove to be costly. For this reason, the square root is generally omitted in Euclidean distance. Now coming back to our topic, we have Euclidean distance in reducing the error in the detection of the color sensor. When the sensor turns on, it continuously reads signal and shows the corresponding red, green and blue components. Due to various environmental factors, these values keep fluctuating, and very often we see that these values are constant for a particular color. Even a variation of 1 can be fatal when you're trying to detect a wide range of colors. And for this reason, we have decided to use Euclidean distance to improve the accuracy. The following code snippet will be implemented for Euclidean distance. First, we declare two variables. The first is to keep track of the number of successful readings by the sensor, and this will increase each time it reads the RGB value for a color. The second one will define how many readings it must take before displaying the final output and by mapping it to the corresponding RGB values. Further, we can use a data structure like an array to store these RGB values or these data sets and use the Euclidean distance formula to display the final value. This will ensure that our accuracy is increased and the environmental factors are reduced. The device is cost effective and can perform multiple tasks without the need of human interference, which will reduce the probability of error. Additionally, advancements and rapid progress in this field of robotics and machine learning technologies are likely to develop the capabilities of the color detecting robots, making them even more valuable in the future. In the upcoming years, the need for such devices is anticipated to increase as the nation continues to place a high priority on innovation. In conclusion, a color detecting robot is a useful device and its applications in various fields are expected to grow.